Hello, in this video we'll see about what is consumer indexing and GIS based consumer indexing in electrical distribution system. First we'll see what is consumer indexing. Consumer indexing in the power distribution sector refers to the process of mapping every electricity consumer, that is a customer, to their respective electrical network asset like connected pole, distribution transformer, belongs to which feeder and belongs to which substation, and geographical location, that is using coordinates latitude and longitude locating the consumer location. Connection details like consumer ID, meter number, and load, it's a 2 kilowatts, 5 kilowatts, like that. Phase like RYB or XYZ, which is classified, and a tariff. This process creates a one-to-one link between the physical location of a consumer and the corresponding electrical infrastructure. Okay, that is a location based infrastructure mapping about the consumer. Importance of using GIS in consumer indexing. GIS enhances the indexing process by enabling accurate mapping of each consumer on a geo-referenced electrical network. Visualization of a consumer spread across the network. Okay, so in the HT network and LT network, the poles and the transmission lines, and where all the consumers are connected, that geographically we can visualize on the screen. Efficient traceability from a consumer to feeder or a transformer, that is the consumer connected feeder or connected transformer or connected substation. The upstream traceability, the downstream traceability from the feeder, the down to that feeder, a number of consumers are connected and their geographical locations. Similarly, the transformer and down to that the consumers are connected and the geographical locations. Integration with the enterprise systems for real-time analytics, even the asset management, okay, and outage management systems integration about the consumer location and the details. Next we'll see integration of GIS and consumer indexing. First part is data collection. That's a field survey using mobile GIS tools like collector apps or survey 123 or a Q field. Okay, using those devices we can collect the consumer location and capture consumer details, photos, coordinate, and electrical connection points, that is a service pole details. Next, electrical network mapping, that is digitizing the LT network including poles, conductors, DTs, that is a distribution transformers, feeders. Create a spatial connectivity using utility network or a geometric network, which you prefer to that connectivity. The hierarchy and the connectivity should be established. Consumer mapping. Link each consumer to the nearest pole or LT conductor. Validate their location on the GIS map. Database integration. Merge GIS data with the CIS, that is a customer information system, and MDM, metadata management system, and assign a unique IDs for every asset and consumer. No duplicates should be there. QA, QC, and validation. Use spatial queries to check data quality, unlinked customers, duplicate records, missing locations, like checks. Dashboard and analytics. Create web maps, dashboards for insights, like feeder wise losses, DT loading, revenue versus consumption, that is actual load versus a sanctioned load. Okay. Next we'll see real world use case, GS plus consumer indexing. That means GS based consumer indexing advantages in a real world. Assume a distribution company used GS based consumer indexing to map over 30 lakh consumers, digitally model the electric LT network, link each consumer to the corresponding transformer and feeder. The outcome is reduced AT&C losses from 25% to under 15%. This AT&C aggregate technical and commercial losses, I will do in a separate video what is that and how it has been calculated. Enable faster consumer problem resolving and load management. Next we'll see benefits of GIS based consumer indexing. Targeted load reduction, that is helps a pinpoint area of high AT&C losses where aggregate technical and commercial losses are high. We can focus and we can try to reduce. Load balancing, that is accurate distribution transformer wise and feeder wise consumer load, that is if it is a single phase connections RYB, okay, red, yellow and blue phases, the balancing. Asset management, that is better planning for upgrades, preventive maintenance. Revenue protection, that is identifies unauthorized connections and meta tamperings. Improved customer services, that is a faster fault tracing and compliant resolution. Data driven decisions, like integrating with analytics and AI for outage prediction. Next we'll see future trends in consumer indexing, specifically in electrical utilities. AI and ML for load forecasting, that is predict consumer demand patterns based on geospatial plus meter data. Smart meter plus GIS integration, it's real-time consumption monitoring and outage detection. Drone based mapping and validation, there's the aerial surveys for inaccessible areas, that is some of the places it's difficult to reach the field crew to capture the details. There we can send the drone to capture the details. A digital twin of LT network, it's a real-time interactive 3D model of consumer network ecosystem. Cloud-based GIS platforms, that using ArcGIS Online and AWS or Azure cloud platforms for scalable indexing. Thank you very much. Please subscribe. I will come up with many more videos using GIS in utilities. Thank you.